In this video, we are going to design a dark sensor. Yes, you and I, we are going to design a dark sensor. We are going to start from the basic circuit theory, through the simulation using photo-use, and finally conclude with a prototype on the breadboard. But before we get started, my name is Kenny Jacques, and I am a holder of a bachelor degree in electrical and electronics engineering. In this channel, I share with you my experience as far as engineering is concerned, some of the things I wish I knew and did back then in order to stand out and make a difference in this field. Without wasting much of the time, let's get started. We are going to make use of a breadboard. We are going to make use of two batteries, each of 3.7 volt, combined in series in order to obtain roughly 7 volt. We are going to make use of an LDR, which is the brain of this circuit. We are equally going to make use of a LED. We are going to make use of two resistors, one of 220 ohms and another of 100 kilo ohm. We shall equally make use of some jumper wires to connect the components together. And finally, we are going to make use of a transistor. Here, I am using a 2N222 transistor, but you can use any other transistor of your choice that can perform switching. Before we continue, it is important that you know what a dark sensor is. A dark sensor is simply a sensor capable of detecting the presence of darkness or the absence of light and initiating a particular action depending on your need. For our case, we are going to detect the presence or the absence of light, then turn on an LED. Here is our circuit diagram. As you can see, we are going to have the battery connected here, a battery of 6 volt, and we are going to have our LDR connected to the ground and to the base of the transistor. And we are going to have our 100 kilo ohm resistor connected from the base of the transistor to the power source. So now, in the presence of light, here is what happens. Current is going to flow from here to here. But now, since the resistance of the LDR is very low, close to 0, all the current flowing in this path will prefer to flow through the LDR and go into the ground. And none of the current is going to flow to the base of the transistor. And then the LED is not going to shine since the transistor will not be activated. But in the absence of light, the current that flows from the power source reaches here and flow to the base of the transistor, activate the transistor, and the LEDs shine. Because in the absence of light, the resistance of the LDR is very high, close to infinity, and then no current will prefer to flow through the LDR. So all the current from the power source is going to enter the transistor. Now for the simulation, let's enter our software, photo-use. Again, if you don't know how to use photo-use, drop a comment down below and we shall maybe do a video in order to help you in that. So the first thing we want to do is to pick our components. To do that, simply come where you see this P icon. Left click there and you can start writing the name of your component. So we need a resistor. We are going to use the generic. Since we have several components to pick, we are not going to hit enter, but instead we'll double click on the component and the component will be selected. We're going to do same for the LDR. We are going to use the touch LDR. We are going to use a resistor. We already have that. We are going to use a LED. We are going to use the red LED. Make sure you take the active LED. We are going to need a battery. So still take the active battery, and I think the last component we need is the transistor. And we said we are going to use a 2N222 transistor. So just search the 2N222 and here it is. So now we can hit enter. Now we are going to design our circuit. So now that we are done designing the circuit, it is always important to put a ground. So we are going to come here and we'll place a ground at the emitter, connecting the battery and the LDR as well. So let me zoom in so that we can see what is going on. First of all, we are going to change the resistance R1 to 100 kilo ohm. And we'll change the resistance R2 as well to 220 ohms. So remember, this is a dark sensor. So when there is no light, the LED is supposed to shine, and in the presence of light, the LED is going to be off. So to run the simulation, simply come down at the bottom left of your screen where you see this play button and click on it. Now the simulation is running, and you notice that immediately the LEDs start shining. This is because the torch here has not been turned on. Now to turn on the torch, simply click on the arrow pointing upward. Click several times, and you notice that the more you click, the torch gets closer to the LDR and the LED stops shining. If you click on the arrow facing downward, the torch gets far away from the LDR until it goes off, and you notice that the LED is turned on. For the prototyping, we said we are going to use a transistor, 2N2222 transistor. So if you don't have the 2N22 transistor, you can use any other transistor that can perform switching. For this transistor, this is our collector, and in the middle we have our base, and this way we have the emitter. You can always download the datasheet of your transistor to know the pin configurations. So now we are going to place our transistor here. Now we know that for the dark sensor, the LDR is placed from the base to the ground. So we are going to place it here. We are going to assume that this is our ground. So we are going to place it here. And equally, the 100 kilo ohm resistor is placed from the base to the power source. So we are going to place it here. Let's say this is our power source this way. For those of you who don't know how to use a breadboard, you can leave a comment down below and we'll see how to attend to you, maybe by making another video. So now, the 220 ohm resistor leads from the power source to the LED. From the power source to the LED, and from the LED, it goes to the collector of the transistor. So that is it. So this is going to be our power source, the positive terminal of the battery, and we are going to connect it in series like this, and this other terminal is going to be our ground. But before we continue, we equally have to ground the emitter by, so here is going to be our common ground, this way. So we are going to use this wire for our grounding. Now let's see what happens when we power the circuit. This is our ground. We are going to connect it here. By doing that, you can notice that the LED shines immediately. Take note that this is in the absence of light. Let's see what happens when we put a light source on the LDR. So in the absence of light, the LED shines, but in the presence of light, the LED goes off. So this is how a dark sensor is designed. We have come to the end of this video, and we hope you got some value from it. Thank you all for watching, and see you in our next video. Peace.